Okay, so you can see my screen, right? And let's do slideshow from beginning. All right. Okay, so let's go over first. Let's say oh, this is your homework question. You let me look at the so let's try to do that in class. Give you answer key. So the question was create a ERD diagram, ER diagram for clinic to keep track of the patients. So it's clear that the patients objects that you need to keep data, and then appointments. That's basically just like a concepts, right? Appointment typically like have a data like appointment date, appointment reason, right? And then maybe some other attributes with whom, with which doctor, right? And then doctors is attribute is object indicated here, and also visit. Understand the difference between appointments and visit. Appointment is just appointment. Okay, it's just like a reservation thing, and the visit is going to be actual visit. So you actually visit the doctor, visit the clinic, and you get treatments, right? Get a procedures performed. So that's a visit. So then you convert ERD into relational model. So first of all, let's do let's say let's draw ER diagrams. So I'm going to use whiteboard. So let me switch to this screen so that you can see. Okay. And now let me see. Let's go create a new blank whiteboard. So first of all, we are going to draw the major objects. So first one is patient. Okay. And then doctor. And then let's just put appointment. And the visit. Okay, so the four major objects. Now, if you go to the question again, so we have those four objects captured, right? And then let's say we can throw some attributes into the picture. So for example, for patient, we may have patient ID, right? And then we have a patient last name, patient first name, right? And then what else? So let's just make this last name required, first name required. And then we may also have like a patient phone. So let's say this optional. Okay. And the doctor, of course, is going to have employee ID. Okay. And doctor's last name. So that's required. This is a punch sign. So his ID is identifying, EID. And then we may also have this last name. Okay. And then we may have like a field, right? Field of expertise. So let's make this required. Okay. And for appointment, let's also create ID, say appointment ID, appointment date. Okay, so that is required. This is ID. Okay, and then appointment reason. So let's just say reason. Okay, so that as appointment, and then visit. Visit is just more like a treatment. So let's just say that is a visit ID, visit date required. Okay, and then visit date. What else? So visit actually is going to have a lot of data. So like prescriptions, test, all that. So I'm going to skip most of the stuff. So just say just put one thing here. Suppose for each visit you're going to have like a vital signs, right? So vital signs like include your blood pressure, your weight, your height measured, maybe like a heart rate, right? So that is not a single valued attributes. So we probably have to use awake entity for that. But that's not required, okay? So just let you know that for homework, I may not, I will not say you have to have that. So let's just put vital sign here, and that is weak entity, okay? And the vital sign, so may have some kind of like, so for each visit, you're gonna have multiple of this vital sign. So for each one, you have like a V vital sign number, right? Okay, and the vital sign name, okay, is required, and then a vital sign value. Okay, so a vital sign name, like say blood pressure, right? Or high pressure, low pressure may have more distinctions than what is the value of the high pressure or what is the value of low pressure, all that. Okay, so then that would be very that's good enough, if you consider vital signs. So, but as I said, this part is not going to be required for grading. All right, now let's see how can we connect the things. Okay, so apparently, patients is going to make appointments, right? So one patient can make many appointments. Each appointment is just for one patient, right? And the patient may or may not have appointment, so I'm going to make this side dashed. Okay, let's do it again. Okay. And each appointment is going to be appointment for doctor, right? So let's just say each appointment is for connecting to one doctor. So appointment is for this doctor. So let's just make that, all right? And each doctor may have many appointments too, okay? So that is also one-to-many relationship. All right, and the doctor may or may not have appointment either, so let's make this dashed. All right, and next, visit. Of course, visit, doctor, patient pay for visit, so that's going to be, I'm going to, instead of crossing, I'm going to connect it this way. Okay, so each patient may have one or more visit, okay, in history. And the patient may or may not have any visits. So I'm going to make this side to be dashed again. Okay. And then each visit is going to involve doctors, right? So let's just say how many doctors have been involved. So typically one doctor can be involved in many visits. All right. And then one visit, if we're talking about just a primary doctor, then that would be just one. Okay. Primary doctor. But if you're going to do this for like for a hospital, each visit going to involve many doctors, so you can put a many here. Okay, and then a doctor may or may not have any visit. A visit may or may not have doctors either, right? So the spell site will be optional. Does it make sense? So I'm going to use dashed lines for all of them. Okay, so both sides are dashed. Okay, and then what about other relationships? So appointment and the visit, well, one appointment is for one visit, and one visit is result of one appointment. Okay, but appointment may or may not be may not result in any visit. For example, visit may not be, may not be actually not appointment may not actually being performed. So I'm going to make this side to be dashed. Okay. So there we go. So that will be simple ER diagrams for your homework also. Does anybody have questions? Okay,
Yes.
if not, yeah.
So you wouldn't put a relationship between patient and doctor? Because I was just thinking like a doctor would have many patients, but a patient would only have one doctor.
That's a good question. So the question is, what is the nature of the relationship between patient and doctor? So if you say patient see doctors, that's a visit, right? So you have to connect them through visit, because you're going to record the data on the on the visit, right? So there's no direct relationship between patient and the doctor. If you have some other kind of relationship, say a doctor is just assigned to a patient, that might be the case if you have insurance policies like HMO. Each patient does have one primary doctor assigned. So in that case, you can connect them. So that basically just say a patient is assigned to the doctor, and doctor is assigned to the patient. So that will be assignment question. So that could be relationship. Okay, so then one patient has one primary doctor to be assigned, and one doctor has many patients like that. That is possible, but that relationship is not a C, it's not a visit. Okay, so this relationship should be assignment. Okay. Does that answer your question?
Yeah, I get it.
Okay. Anybody else has questions?
I also have a question for the same thing for the patient-doctor relationship. I connected it with have, like patients have doctors and doctors have patients. Would that be considered wrong?
What does it mean by have? What is relationship? What do you mean by have? That basically I'm asking you.
Okay, so that would be wrong, I'm guessing then.
I'm not saying it's wrong. So don't. I'm asking you. So what do you mean by have? So in what sense a doctor has a patient?
I guess like doctors treat patients.
Or treat a patient. So if it's treat patients, then you have to go through a visit.
Okay.
Because that's a treatment, right? So you have to go through a treatment. So you need to record data on treatment. So therefore, treatment should cut in between doctor and the patient.
Okay. Thank you.
Yeah. Any other questions? All right. So if there's no other questions, I'm going to convert this to ER diagrams. Okay. Convert this to relational model. So first of all, we are going to have 1, 2, 3, 4, 5 boxes, right? So that's very simple one. So you're going to have patients. Okay. Patient has patient ID, which is primary key. Patient last name, which is required. Patient first name, that is also required. And the patient phone number, which is optional. Okay. And then we will have doctors. So let's put doctors here. Doctors going to have doctor ID or employee ID, sorry. employee ID, which is ID, and the last name, which is required, and the field of expertise, that's also required. Okay, then we do appointments. Appointments have appointment ID, appointment date. Appointment ID is going to be primary key. Appointment date is required, and appointment reason. So for what reason you see doctor, right? So that is also required, I believe. Yeah, required. And then we have visit. So let's do visits. So visits could be handled as treatments. It's just synonym. Okay, so visit ID and a visit date, which is required. And finally, we have weak entity visit vital signs. So I'll put here vital signs. So that basically is just a list of attribute value pairs. So VS vital number. So that is just vital sign 1, vital sign 2, or that, right? So that vital signs can be only uniquely identified through the visit. So if you're given the visit and then the vital sign 1, 2, 3, so then you're sure that that vital sign is measured during that visit. And the vital sign name required, and vital sign value required. Okay, and then the vital sign number is a part of primary key, so weak entity does not have a primary key. Okay. All right, now let's handle relationship. Yeah, any questions? Yeah.
Is it okay for our homework if we represented the primary key by bolding it instead of underlining it?
By bolding it, yeah, you can. Yeah.
Okay.
As long as it's clear. Yeah, that's fine. I like to use, I cannot be bold, I could just underline. That's fine. Okay. All right, so now let's say if you have weak entities, I said you need to handle weak entities first, okay? So now we have one weak entity, so we need to handle that first. So basically there's a one-to-many relationship between visit and the vital sign. So you're going to duplicate the primary key from visit into vital signs. So you have to duplicate this VID into here, but we can call that as VID, or we can just simply call that as a visit, okay? That is, you can, for foreign key, you can change your name, right? You can change foreign key name. And what about the requirement? Is that column required to have values? So let's look at the relationship here. This side is solid here, right? This side is solid. So that means vital sign does have to be required, does have required to have visit, okay? And then finally, because of this little bar, and then we have to make sure that the foreign key received has to be part of a primary key. So then you have to underline this too also. So then what is the primary key for this vital signs? Is going to be, is going to consist of 2 columns. Okay, so VS number and also visit. These both columns will make a composite primary key. So this is composite PK for this table, for that table. Okay, so that's how we handle the weak entities. And now let's handle all the relationships. So let's say, first of all, patient and appointment. Patient appointment, one and the many side, appointments many side. So I'm going to duplicate the primary key, patient ID into here as a foreign key. So I'll circle that. And then I will, what about requirement? So this side is solid actually, right? This cannot be seen here, but each appointment definitely have to have appointment. Each appointment definitely will have a patient. So this is required. Okay, so if you want to draw a line here, just draw the line like that. Okay. So then we handled this relationship. Let's do it again for patient and the visit. Patient and visit is pretty much the same thing. So I'm going to duplicate primary key from patient into visit, one to many, right? So I'm going to make PID here as foreign key, and that foreign key is also required. Okay, because of this side is solid here. See that? Receiving side, the visit side, the receiving side as solid. Okay, so we handle the two. And now we have, let's just say, assuming that we have relationship between doctor and the patient, so that basically doctor is assigned to the patient. So then in this case, we have a relationship like one to many here. Okay, so then we have to duplicate primary key from doctors into patient. Okay, doctors into patient. So I'm going to create another column, and then we can call that is doctor assigned, or maybe just call the primary doctor. Primary prime doctor. So that is the case with insurance. HMO, you cannot see. You do not have flexibility to see arbitrary doctors. You have to see your primary doctor for any disease. So then that relationship should be like that. Okay, this primary key duplicated here as a primary doctor. All right, next we have a relationship between doctor and appointment. So doctor appointment, doctor side is one, and appointment side is many. So we're going to duplicate the primary key from doctors into appointment. So I can put here. I want to. Okay, so I can just say this is doctor as foreign key, and that relationship is like this. Okay, the doctor duplicated here, and that is also required. If you look at this solid line here on the appointment side, so that will be required. So this doctor is required foreign key. You may ask, does it matter if I put in a column? Sometimes I put in the end, sometimes I put a beginning. Does that matter? Yeah, no, it does not matter. You can put you can arrange your column in any order. That does not make any difference. Okay, so you can just insert into the end or beginning. All right, next we have that handled. So this time we have multiple relationships. You might need to just make sure you did all of them. And then we have a many-to-many relationship between visit and doctors. So between visit and doctors, we have a many-to-many relationship. So I'm going to create junction table maybe here. Okay, so that. So how do we name that? Let's just create a junction table first. Okay, so in that junction table, you're going to duplicate the doctor, which is employee ID, into here. And also you're going to duplicate the visit ID. So let's just name that as a visit. Okay, and for junction table, the foreign keys are always required. So you do not need to think. Okay, and then those foreign keys will make a composite primary key for that table. So how do we name this table? So basically, this is just like a doctor visit. Which doctor handles which visit, right? So how do we name that? So if we cannot find a proper name, we can just use few letters of each table. So doc visit, something like that. Okay. So indicating that this is a junction table between doctors and the visit. All right, so this junction table is going to have a primary key consisting of those columns, doctors and the visit. Make sense? Okay, and I think we have one more. That is between visit and appointment. There's a relationship one-to-one. So for that, we can do either way. We can put a visit ID into appointment or appointment into visit. Okay, So if you're going to put a visit, visit ID into appointment, that a receiving site is dashed, so then that foreign key is going to be optional. So we can do that with appointment. So let's just do it here. Let's do it here. Okay, so that's the VID as a foreign key. Okay, and that is optional, so let's put O here. Okay, and then we can connect this to visit here. Basically, this is relationship. Okay, so this is this ID we're duplicated in appointment. That's a one-to-one relationship. Or we can do the other way around. Okay, so there we go. So this is complete relational model or Bachman diagram we produced from this ER diagram. Any questions? Does anybody have questions? No question? All right, so if there's no question, let me say whether, so I'm going to go through, let's see which from beginning here. So this one we did, okay? So now this is about the forward engineering review. So we already did that, so I'm going to skip that, right? Depending on mapping cardinality to modify tables to make them related. So one to many, many to one, you duplicate the primary key from one side into many side. If it's a many, you create a junction table. If it's one to one, you duplicate primary key from any side to other side, okay? And then with respect to optionality of those foreign keys, the receiving side is optional. If you have one-to-many or one-to-one relationship, then the foreign keys will be optional, otherwise will be required. And the junction table, foreign keys will all be always required, okay? And how to handle weak entities and associative entities, the little bar. So the only thing that difference is that when you duplicate primary key from one side into many side, you need to make sure that foreign key is part of a primary key for the weak entity table or associative entity table. Okay, other than that, this is so this is the example we did in the last class. Okay, we did the customer account transaction employee. We did this example too. And then we did this example in the last. Okay, so basically this one we have weak entity here. So we have a student, checkout, a book copy. A book copy is a weak entity of books. All right, so in that case, first of all, you create 4 tables, right? Student table, books table, checkout table, and book copies table. And then you need to handle weak entities first, okay? So because the one-to-many relationship between book and a book copy, so you're going to duplicate the primary key of book into book copies. So book ISBN number into book copies into here, okay? As a foreign key. And then because of this little bar, we have to make that foreign key as part of a primary key for book copies. So now book copies has a primary key consisting of both columns, copy number and also ISBN number. Okay, so that is very important. Okay, and then we have one-to-many relationship between student and checkout. So duplicate student ID into checkouts. We did not do that. Okay, so in here we actually have to create another column here, another column for the student ID in here. I did not do that. That's not. So that we will rush probably. Okay, so yeah, so this one has a minor mistake, is missing a column, which is a student ID duplicated here as a foreign key. Okay, and then finally we have a many-to-many relationship between checkout and the book copies. So we create a junction table. So junction table will have a transaction checkout ID, transaction ID duplicated as a foreign key, and also primary key from book copies will be duplicated. Book copy, remember, has 2 columns as a primary key, so you have to duplicate both together. Okay, so now if I'm asking you how many foreign keys does this table have, if you say 3, that will be incorrect because we have only 2 primary key duplicated. This is one primary key duplicated, and this is another primary key duplicated, both together as one primary key duplicated. So therefore, we have 2 foreign keys in this case. All right. So the only mistake we did with last class we had was this one. Is we're supposed to have another column student ID in here. Okay. All right. So we are going to get into SQL in the next how much time? 40 minutes maybe. So SQL stands for Structured Query Language. Okay. It's a programming language, but this programming language is not, you may feel that it's not the same as the programming language you learn in C# class or Java class or maybe C++ class, because this programming language has two special features. One special feature is so-called non-procedural language. So SQL is non-procedural language. What is a procedural language? Procedural language basically just lay out the procedure step by step, logically and procedurally to reach your target. So for example, if I'm going to say I want to program my robot coming from this corner to another corner, I will basically tell the robot how to reach the final destination step by step. Okay, so maybe move forward 4 steps, and then turn right 2 steps, and then turn left 2 steps. That kind of, you have the steps, you have the steps, use programming, use commands or statements to lay out those steps step by step. Okay, and then finally you reach the target. What about non-procedural language? Non-procedural language is basically you do not need to specify those steps. Instead, you are telling your robot, say, okay, that is your target. Okay, and then you find your own way to get to the target. And then basically, in that case, the robot has to find his own way to reach the target. Okay, so the key requirement for that is you have to precisely define your target. Okay, if the target is fuzzy, is not clear, then your robot will have ambiguity for robot. Robot will not be able to say what is my target, what is my destination. Okay, so the most difficult part for SQL is you precisely specify what you want, precisely, no confusions, no ambiguities. Okay, so that is the first feature. The second feature is we talked about 4 generations of language, 5 generations already. Okay, and the first generation, that was in 1950s, 60s, with people basically program. When we talk about programming, we basically use machine code. Okay, use a machine level language. So that's 4th generation language, which is not you understand that the machine only speaks 0 1s, right? So that is not really kind of is pretty critical. Human programmers seldom understand. Okay, and then 2nd generation language is mostly example is assembly language. That if you learn computer science, you probably still have to take that class called assembly language. In older days, all the Windows, those operating systems were created by assembly language. Okay, and now I think that they are using 3rd generation language like C or C++ to create Windows, create operating systems. Okay, so the 3rd generation language is pretty much machine independent, and also is more the programmer friendly. It's not programming friendly, programmer friendly. So basically, is the language, the code, whatever the statement is pretty. It's all in English. It's pretty much close to our daily English. Okay, pretty much. But it's still, they are still procedural oriented. So you have the declare variables, and then assign put values into variables, and then manipulate the variables, and then output those variables. So basically, you have to follow this kind of like a order to be able to program in C#, Java, those 3rd generation languages. And now it comes to 4th generation language. So basically, 4th generation language, as we will explain, we will see just in a few minutes, is very much like our English, plain English. Okay, but it's more precise and more structured. That's it. Okay, so the examples of a 4th generation language is SQL, R, HTML. So those are the examples. You probably, SQL is what we're going to learn. HTML is language hypertext markup language. Is the one used for for website or for web pages, right? R, you know, the R is a primary analytical tool for doing business analytics. Okay, so those languages are fourth generation. What about fifth generation language? So this, I'm going to tell you that in the future, the programming is going to be more like drawing diagrams. So for example, we draw ER diagrams, right? So your ER diagrams may be executable in the future. Okay, so that is the future direction of programming. All right, any questions? Okay, now SQL consists of two parts. Okay, first part is DDL, data definition language, and you use data definition language basically to create, modify, and delete database objects. So what are the database objects? Database objects like users, user accounts, tables, views, indexes, triggers, stored procedures, functions, table spaces, table database links, all that, okay, sequences. So those are the things, objects inside Oracle, inside database management systems, okay? And the tables, we understand is a primary tool for holding data, right? But data has to be secured, so we have to have accounts. We have to have user ID and a password, right? And the views is just say when we have like a query and I want to save it, and then we'll save into views. Indexes, you understand index, right? Index, say for example, just use your common sense. So for example, if you go to the library, if you don't have an index, and how do you find your book? You pretty much have to look for every book from beginning to the end in order to find your own book, right? So that will take days and maybe some months or even years to find your book. So that is not very efficient. However, if you have an index, just find where, find the title and then find the index of the book, and the index will tell you where is the location, and then you through that index, you find your book. Just directly go to the book, the shelf and the location, and then you can find your book. So that would be fastest way to get your your book. So that same idea applies to data. So you have a lot of records, and all the records will be indexed. Okay, so for Oracle, for DBMS to find your records, and you basically they have to use the index to search for the records, location of the records, and then go to the place to find the records. Okay, and triggers is just like those, some kind of like agent programs that will automatically be activated if you do something with your data. For example, if you you set a trigger on employee salary. So if somebody changes salary, then trigger may be triggered, activated to save your data to some kind of like a log place, so that you can always go back to say who did the changes and what was the value before and what has been changed to. So then the triggers can help you to automatically track the data activities, in case those data is very very critical data, very sensitive data, and then you can make those triggers to activate whenever something, those important data has been changed, modified, or deleted. So the trigger is doing that. Stored procedures functions, just those functions or procedures programs that are stored inside the database. So that will basically help you to automate some of the data activities. So anyway, the DDL is basically help you to create, modify, or delete all those kind of database objects. And then when it comes to data manipulation language, basically data will be stored in tables. So we are going to use DML to create new records, to modify records, to delete records, and then retrieve data in the records, right, in the tables. So basically those we are going to spend 3-4 weeks on that in the second period of the class. Okay, so after the first exam, we are going to do that. So today and the next week, we'll be doing DDL. Okay. Any questions? So here is a simple syntax for creating tables using DDL. Okay. So create table, that's keyword, and then the name of table, you make up the name of table, and then you specify the columns, column 1, column 2, column 3. For each column, you specify what is data type. Okay, and then say char or text is char or number or whatever, and then you can also specify some other constraints, like for example, this column 1 is a primary key, or column 1 has to be unique value, or column 1 cannot have a missing value, or that, right? So we can do that too. So here is an example. So I would say, suppose I want to create a table of students, okay? So student is going to be 7 digits characters, and then last name, 45 characters, first name, 45 characters, state, 2 characters, city, 25 characters. So this table does not have any constraints like primary keys, like whether the value should be required or not. Okay, so those, they are not there. So let's say, yeah, this is another example. This example basically is the more extended syntax. So basically column, and then data type, and also you have constraints. Okay, so you can also just list the constraints separately from those columns. Okay, so let's say suppose, so that I put 3 types of constraint here. The primary key is constraint, foreign key is constraint, check constraint, and also there's a unique constraint. So some values you want to be unique, you can also make that unique constraint. So 4 types of constraints, okay? The check constraint is the most prevalent, most popular one. So you're going to use check constraints to check, to implement the business rules, okay? So for example, you can say, or student grade, okay? Student grade can be only a value like A, B, or C, or D, or F. So then you have to use check constraint to implement that, okay? And here I have an example to show that there are constraints. So besides those list of columns, and also have one more thing, that is a constraint, PK, that's the name of the constraint, and then primary key, and indicate that student ID is a primary key. Okay, so we are going to use this to implement a bunch of the examples we did in last class or homework. Let me see which one I should use. So I'm going to exit. Hold on. What time do I have? I have only 2 minutes left. Oh my gosh. This 50 minutes class is really wasting a lot of time. So I guess I will stop here. I cannot do anything in that 2 minutes. It's 2:48, right? 2:48, yeah. So 2:50. That's just 2 minutes. All right, so I'm going to say Friday, okay? So make sure you have Oracle SQL developed ready for next class. All right, so I'm going to stop here.